After releasing a video that's almost 1 hour in length about Elon, Tesla, and autopilot, I thought I was done making videos about Tesla for a while. But here we are.
Just when I thought I was out, they pulled me back in.
Thanks, Al.
Hoo-ah!
I've been working on this video for a couple months now. It's just that the situation keeps changing with new revelations and unthinkable events. Every time I thought I was done with the script, something new happens, and it's just been really tiring and difficult to stay on top of all of the events. So to avoid a feature-length YouTube video, I've split this topic up into 3 separate videos about Tesla's FSD Beta testing. In this video, we'll talk about whether or not Tesla's FSD Beta testing is actually testing in an engineering sense. In the next video, we'll cover whether or not the FSD Beta testing is safe. And finally, we'll talk about whether or not FSD Beta testing is legal. I want to get all my thoughts about Tesla's FSD Beta testing out there so I can move on and talk about something that's not Tesla, because there's so much happening in the AV space, both good and bad, that has nothing at all to do with Tesla. But if we're to use a metaphor, the AV industry is a house and there is a room in the house that's on fire. It would be irresponsible to be calling a glazier to replace a broken window when there's a room on fire. Tesla is that fire. In these videos are my call to the fire department, and I guess you're the fire department. The metaphor breaks down after that point, but well, let's get started. And before we talk about whether or not Tesla's FSD Beta testing is actually testing, let's understand what testing is in an engineering context. Testing is an important part of the engineering design process. Regardless of whatever it is you're making, if you don't test it, then you can never be sure that what you plan to build is the same as what you ended up building. Testing will look different depending on the field of engineering that you do. A civil engineer will likely test the material being used while building to ensure that it has the same qualities that they planned when first designing whatever it is that they're building, while a software or computer engineer will need to test their computer to ensure that it doesn't have bugs. For the purpose of this video, I'm going to stick to a context of computer, software, and systems engineering. Look, you other engineers get to wear hard hats and lab coats and get to be called real engineers, so quiet, this isn't for you. But within software engineering, you can test in many different ways. This can range from an extremely informal code for a bit, then check if you've solved the problem, then wait if someone complains about it, which is not recommended, all the way to doing something called test-driven development, where you write a bunch of tests which describe what your program should be able to do before you even start to write your program. And then your program is pretty much the minimum amount of code you need to make each test pass. I'm not going to get into which way is better. If you're interested, go to medium.com, search software testing, and be prepared to have your opinion on everything be wrong. But regardless of whatever testing paradigm you follow, a test is a very normal part of the engineering process, and failing a test doesn't mean you haven't done your job well, again, in the context of software and computer engineering. It's a regular part of development, and finding conditions under which your program will fail has an entire engineering discipline devoted to it. Now, since autonomous vehicles are software driven and they're engineered, then testing is going to be one of the most crucial steps in their development. But what does testing for an autonomous vehicle look like? There are so many different approaches to building an autonomous vehicle, and the one a company chooses depends on what the end goal of that vehicle is. Not everyone is after level 5 autonomy, and that's okay. And this can range from a rules-based approach on one end where you tell the vehicle what it should do in every instance, to a data-driven approach where you collect data, show it to the vehicle, and let it decide how to act in a new and never-before-seen situation, and sometimes it's a mixture of these approaches. But how does the development cycle of an autonomous vehicle system work? Well, let's put it on a timeline. On this side, the earliest part is when you decide that you're going to make an autonomous vehicle or design an automated system. On this other side, here, the final stage is when you take the perfect system you've designed and you've shipped it or released it out to the world. Now, you can't go from sitting in a boardroom or a diner with your plans on the back of a napkin to shipping a safety critical system out to the world in a snap. So to link these two ends, we need the iterative engineering design process, TM. This process is the core of any software engineering development, and it goes design, code, test. Once you do this for the first time, you'll likely fail those tests, and that's okay. A failing test lets you know what you need to work on, and some approaches like test-driven development rely on you failing these tests as part of development, so don't sweat it. But once you've seen what tests and conditions you failed under, then you go back and plan how you're going to fix that problem, code the solution, then test again, and you just repeat this over and over and over again, and eventually you'll have a chunk of code that should hopefully do all the things that you want. Once you have this though, you can't just push it out to the real world. You need to be able to do some more rigorous testing. This can be a simulated step where rather than driving it in the real world, you create a fake or simulated world and see what your program does in that. The weakness of a step like this is that you're only testing against the simulation. So if your simulation is not exactly like the real world, then your test coverage or the things you're able to test for are going to be reduced. But it could still be a good way to find major issues. There's all sorts of other in-between steps like Tesla's shadow mode, for example, which is a type of testing that runs new software out in the real world in parallel with a person driving, but not allowing the software to control anything. You then see whether or not the human and the software make the same decisions when presented with situations and concentrate on the ones where they're different from each other. However, at some point, you need to test your vehicles out in the real world. First, probably on a private road, but eventually in a live environment with other traffic and human drivers and pedestrians and all the random things that can happen in the real world. This is usually done with a safety driver who is trained and ready. This is a step that has to happen before software is sent out into the real world for normal people. I've heard a lot of people say that public testing of autonomous vehicles should not happen, but the result of no public testing is the release of software into the public that has not been truly tested in that environment before, which is so much worse, you can't imagine. It's just really bad. If the software messes up in the real world, it could lead to an accident where people die. This means that the system is a safety critical system, and the bar for safety, testing, and rigor for these sorts of systems are much, much higher than just normal everyday development. Safety critical systems include things like pacemakers, airplane control systems, nuclear power plant systems, and basically anything where a failure of the system will result in a catastrophic event. This includes systems for the control of a vehicle, since a failure here could lead to injury or death. So let's recap. When you're just setting out to code something, you run a simple test on your computer based on the functionality you're looking for. If everything goes well, then you ramp up the testing and move on to a simulator. If the simulator catches something, then you take note of the situation the simulator tripped up on, incorporate a fix for that in your design, and move back to coding and start again. If the simulator goes well, you may move on to private or closed road testing. If you encounter a bug or bad behavior during private testing, you stop the testing, collect the scenario that you failed at, and you go all the way back to coding with the new information you have, and ensure that the next thing you write won't get caught up in the same place. If the private road testing goes well, then you can move on to on-road testing. When you encounter a bug or bad behavior when you're on the road, you need to take note of that and stop testing the thing it's failing at. Take the new information you have and you need to code that behavior out. Do you notice something here? Testing is the way we seek out new ways our system might fail. We're looking for failures, and we're expecting these failures to happen during testing. Those failure conditions gives us a new set of input or conditions which we hadn't planned for when initially coding our system. And that's a good thing. It means that we can take this new information and make the next version more robust. All these bad events can be written into different tests. All of them composed together is what's called a test suite. This is a software-based obstacle course you take your program through in order to ensure that it runs as expected and doesn't do any of the bad stuff the previous versions of your system have done in the past. So if your system, for whatever reason, doesn't recognize pedestrian crossings, you take an example of when it hadn't detected a pedestrian crossing when it should have, and you add that to your test suite. Now, for every single version that you produce, you'll run it across that test for pedestrian crossings, and you make sure that you never regress in your performance as you keep developing your system. Once our testers are having trouble finding failures in operation, then we look at expanding the testing base and bringing in more people. Do this enough times and you've got a robust and reliable autonomous driving system. Tesla is currently testing its FSD Beta using test drivers employed by Tesla. If they followed best practice, these testers would be tied into the engineering efforts within Tesla and work in an iterative cycle with the engineering team to go out and test development builds of the software to see if a particular issue has been ironed out or not, just like in the iterative engineering design process we talked about earlier. These testers should either be engineers or under the close supervision of engineers to fully understand what it is that they're trying to do while driving, as well as having the training in order to take over in case something goes wrong, or how best to supervise a system which doesn't need direct input from you. It's a different skill set to what you pick up when driving normally. These testers will be getting paid, getting supervised, and getting trained to run these tests. They'd be covered by all forms of insurance by Tesla if they get into an accident, and they'd probably also be under some form of non-disclosure terms in their employment contracts, preventing them from making videos or speaking to the media or public about their experiences. With best practice, this would be something covered by the SAE J3018 standard, which goes into the different types of training, operations, and how best to operate a test of an autonomous system safely, including on public roads. I've put a link to the SAE J3018 standard in the description below. The other testers are members of the public. These are people that Tesla has specifically chosen to try the software. These are made up of the Early Access Program beta testers, or content creators. The Early Access Program allowed owners of Tesla vehicles who Tesla handpicked to receive access to FSD Beta. For a long time, this was the only public glimpse into the FSD Beta people could get, and still to this day these people are like micro-celebrities in the Tesla Twitterverse, and they frequently make videos about every new FSD Beta release. They range in personality from the airline pilot and methodical and responsible Chuck Cook to the erratic Gali Russell of Hyperchange, who tries to see if his Tesla will crash into the Seattle monorail concrete pillars as it slaloms through them. These beta testers are first and foremost Tesla owners, and ones who have paid extra for FSD Beta, and who Tesla has vetted through whatever vetting system they had at the time, and most of the time are also investors in Tesla stock. So there's a bit of pressure, whether formal or not, for them to speak as positively as possible about all of their experiences. And if that sort of informal pressure doesn't do it for you, Vice interviewed a few beta testers recently and learned that they had NDAs with some encouraging language. In the NDA, Tesla says, "Do remember that there are a lot of people that want Tesla to fail. Don't let them mischaracterize your feedback and media posts." Verified further when Gali sent a bunch of DMCA takedowns for footage of when his Tesla tried to drive into some pedestrians crossing the road. In his next video, Gali said this.
But yeah, Tesla doesn't want us sharing all of the clips of the videos, just like when it looks good, because they know people take it out of context. And so I'm kind of mad at myself for leaving that in the video. I'm on better behavior now, being more selective with what I post, because that's the game. It's just like people take it out of context and it's like, dude, this technology is so amazing.
Vice also found out through their interviews that the biggest fear for these early access testers is not getting into a dangerous situation or getting sued by Tesla, but they were most afraid of losing access to the beta program. So there is further pressure here to not let people mischaracterize feedback in media posts, again further shown by Gali when, after he filed a DMCA, said, "I don't want to lose my beta access." That was his biggest fear. It's extremely obvious that the early access program isn't primarily for testing, but for content creation. Tesla famously doesn't have a PR department, instead relying on the notoriety of Elon and self-branded Tesla believers to play that role. So Tesla gave a select and exclusive group access to a cutting-edge piece of technology. In return, these content creators would make videos about them. This is influencer marketing by definition. The same way that your favorite YouTube channel may have a video sponsor, or an Instagrammer does a hashtag ad for a skin cream, money does not need to change hands for it to be influencer marketing. Sometimes access to the product is the payment. The EAP was a way for Tesla to get Tesla content out there while indirectly pressuring these content creators to ensure that there is some positive spin on there. But that all stopped once Tesla started giving access to people that achieved high Tesla safety scores. These tens of thousands of Tesla drivers hit the streets starting in October with FSD Beta to test it. Are they testing though? And I know that sounds like a stupid question, but I mean that in an engineering context. What sort of testing is the testing that they're doing? Watch some of their videos and you'll quickly see that the FSD beta testers are on a mission. They talk quite a bit about sending data back to Tesla and helping Tesla achieve full self-driving. They do this by pressing a button on their steering wheel after every incident. A marker is then made in their driver data so that Tesla's team can review it. But there's no feedback after that. It is a one-way line of communication. A direct link between the engineering team and the testers doesn't really exist. When a new update is released, they are given some brief sentences with regards to changes in the new version, and then they go out and see what it's like. There aren't any specific objectives given. No engineer is saying, hey, that issue you saw where the vehicle didn't slow down for that gate, we patched that out and it should be working now. We need you to go out and try it again. The testers are effectively left to guess as to what the engineers have worked on, and worse still, they go out to check whether a current version is able to handle a dangerous situation with no indication from engineers whether or not this issue had even been addressed by the new version. Case in point, when Gali takes his Tesla to the monorail concrete pillar slalom after he failed to get it through it the first time, he should have stopped going there. The data should have been sent back for the Tesla engineers to work on, and once they have managed to pass under the conditions that the vehicle had failed under, then they would explicitly tell him to try it again. This could happen not necessarily in the next version, but 2 or 3 versions down. There's no need to constantly test with every single version. Instead, there's this really problematic cycle of every time a new release is pushed out, of Gali going down to slalom his vehicle in between public infrastructure in a live environment. It's dangerous and it provides no engineering purpose unless the engineers are actually looking at that problem specifically. Makes for great content though. It might look like testing, and to a degree it is, but it's not testing in a formal engineering cycle for base or safety functionality, or for finding edge cases like the Tesla FSD beta testers would have you believe. It's usability testing. But what's usability testing, I hear you ask? And good question, you're doing such a good job listening. Usability testing is usually done after some software or a product is completed, and the engineers would like to note how people are using it, whether it's easy to use, and if there are some user interface changes needed to make operations more intuitive. On the FSD City Streets Beta, usability testing would usually happen when you're ready to ship FSD, but you're wanting to figure out if the best way to engage with the system is through a button on the steering wheel, or a lever, or something in the center console. You would get customer feedback and you'd iterate on the user experience in order to figure out what's best. Usability testing is usually done with no or extremely limited instructions from engineers because the engineers want to understand what an untrained person will do when presented with their system. That's what they're testing. That's because when you've been spending a long time working on a system, you're going to be making a lot of assumptions about how it works and how best to interact with it. Someone without that experience is really valuable because they can show you some of the blind spots you may have missed in your design that will end up causing issues for new users that will buy or use your product. If you've ever used a program that just seems so intuitive and easy and where you didn't even need instructions, that's a result of usability testing. It's why when you go to google.com, you immediately know what to do and where. But usability testing isn't really there to discover bugs and functionality. You could certainly come across them during the step, but that should be rare. Usability testing is not testing the system's performance. That should already be completed. It's testing the human-machine interface design of the system. When Google designed their search page, the usability testers weren't testing the effectiveness of the search algorithm. That was already sorted. They were testing how easy it was for them to access the search algorithm, which then informed the design of the user interface for their search box and homepage. The type of testing that FSD beta testers are currently doing, if we want to treat it as testing, has a time and place, but it's not during development when the vehicle may do the worst thing at the worst time. It's when the chance of it doing the worst thing is almost nil. The question here is, what engineering purpose do these testers end up giving Tesla? The immediate and most natural answer is that they're there to find edge cases or places where the system doesn't work, and that certainly could be the case. However, the current build of FSD Beta right now, as it stands, is extremely unreliable. In fact, I've made a whole compilation video that shows some of the unreliable situations it gets itself in. Yes, there's some things that it can do well, but a drive with 0 disengagements is such an anomaly that when it happens, it's lifted up as an achievement by the community as evidence of how far the system has come along. This isn't to take away from the engineering work that Tesla has done, that's not in question, at least not on this video. Vision-only autonomous driving in all conditions is a super hard thing to tackle, but the current state, ignoring incoming improvements or extrapolating based on the rate of improvement that Elon constantly does, as it stands right now, today, and in every version so far, FSD Beta is at a level of reliability where a single drive will likely have multiple disengagements. Meaning that employing tens of employee testers, which the company with the 6th largest market cap in the world should easily be able to afford, will be able to find enough issues on their drives for the engineering team to investigate. If you go into YouTube search right now and type FSD beta footage, you can be almost guaranteed to see disengagements on that drive from people who are so heavily invested in Tesla that they are cherry-picking footage of when it's good to make it look as good as possible. FSD disengagements are not rare, and that's not something to be ashamed about when you're developing technology. Every single company developing these technologies will go through a time period like this, and Tesla certainly hasn't made it easy for themselves when opting for the vision-only approach. Kudos to them if they actually ever get a reliable system built. But the current state of progress with FSD Beta isn't that it's so reliable that the engineers are having trouble finding things to work on to make it better. A small testing team, especially when combined with tools like Tesla's Shadow Mode, is more than enough to tackle all the testing needed to find problems right now. Expanding the testing program to more than 12,000 people now, according to a safety recall filed by Tesla, which we'll get into in part 2, isn't something you need to do. In fact, rather than giving you information about what's not working, because you can do that with a team of 50 to 100 employees, it instead creates more work and problems since it increases the risk of getting it in the hands of someone who's going to do something stupid, reckless, and dangerous. And when that happens, the world of autonomous vehicles will be rocked the same way it was in 2018 after the Uber ATG fatality in Tempe, Arizona. It won't result in just Tesla's FSD Beta being taken off the road, but potentially all autonomous vehicle testing, and not just in the US. And that's why this issue is so important to the entire industry. You can't ignore it. But I'm still really struggling with some of my feelings towards this whole testing debacle, because if this was a case of a company who was extremely dedicated to technology and didn't care about public perception, potential fatalities, or any of the many issues that can come from pushing unreliable technology too wide too fast, I could understand and respect that to a degree. I don't agree with it, but I can understand that there can exist an entity who is so driven in the pursuit of technological achievement that they can justify all the dangers that can come about from it. But this is different. There is no engineering reason for the FSD Beta program to be as wide as it is. There are far too many issues with its operation that it just makes absolutely no engineering sense to give it to more people. Why put the reputation of not only your company, but the entire industry and future of the technology in the hands of untrained Twitter edgelords? The belief, echoed plenty in these videos and on Twitter, is that with the push of a button, these drivers are helping Tesla achieve self-driving, when in actual fact, every new unvetted driver that is granted access to the software risks self-driving from happening altogether. Alright, so we've just touched the surface with this issue here. We've gone over whether or not Tesla's FSD Beta testing is actually testing. In the next video, we'll be covering the safety issues surrounding the Tesla FSD Beta. Subscribe and hit the bell if you want to get notified about that. Follow me on Twitter, my links are all in the description below. Thank you so much for watching.